Welcome everyone to this explainer on the Cambridge AS and A-Level Mathematics 9709 syllabus. Today, we are focusing specifically on topic 3.7, vectors. We'll be looking incredibly closely at the dynamics between parallel, intersecting, and skew lines. But listen, we aren't just going to look at the equations today. We are going to treat your mathematics exam strategy exactly like a high-end fashion designer treats a bespoke suit. What does that mean? It means we are going to tailor your answer to fit the question perfectly. No loose threads, no generic off-the-rack responses. Whether you have foundational experience from syllabuses like 0580, 0606, 4024, 4037, or 4040, or you are diving straight into the deep end of 9709, we are going to examine this topic directly through the lens of the examiners themselves. We're going to unpack the theoretical foundations and the highly technical methodologies that separate standard, easily forgotten answers from truly exceptional top-tier ones. Let's get right into it.
Okay, let's dive into this by looking at the actual stakes of the game. You might be wondering, why on earth are we dedicating an entire, comprehensive explainer solely to this specific subsection of the mathematics syllabus? Well, here is the raw truth. This single topic of parallel, intersecting, and skew lines accounts for a massive, game-changing 15% of your total exam marks. I really want you to think about that for a second. Nearly 1/6 of your entire grade hinges on your ability to not just blindly calculate numbers, but to truly understand, visualize, and mathematically communicate the spatial relationships of vectors in 3 dimensions. 15% is the equivalent of jumping an entire letter grade, or sometimes even 2 grade boundaries. It is a highly consequential area of the exam. You literally cannot afford to drop these marks just because of sloppy notation or a fundamental misunderstanding of 3-dimensional space. So, to absolutely secure that 15%, our strategic blueprint today covers 4 critical areas. First, core principles. Second, the procedural framework. Third, critical analysis. And fourth, the examiner warnings. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's move forward and start breaking this down.
Section 1. Core Principles. Mastering the foundations. This is where we build the bedrock of your mathematical understanding. Because grasping these fundamental concepts is exactly what separates the top-tier candidates from the rest of the pack. Here is a hard truth about A-level mathematics. Raw memorization of a vector equation simply isn't enough to secure top marks anymore. Examiners are not just checking if you have a formula sheet memorized, they are rigorously testing you across 3 distinct cognitive domains. First up, we have knowledge and understanding. This is your absolute base layer. It requires total mastery of precise definitions and foundational formulas. For example, knowing that the vector equation of a line is expressed as r equals a plus lambda b. You need to know that a is your position vector, your starting point in 3-dimensional space, and b is your direction vector, representing the path you are traveling along. Then comes the second domain, application. This is where a huge percentage of students completely stumble. Application requires taking that conceptual understanding and transferring it to completely unfamiliar contexts. It's one thing to find the equation of a line when given 2 points. It's an entirely different beast when the examiner asks you to find the perpendicular distance from a point to a line, or find the coordinates of the foot of the perpendicular. You have to adapt. And finally, we have analysis. This is the top tier. This demands that you identify causal relationships and make integrations with other syllabus areas. Can you prove 2 lines are skew? That requires setting up simultaneous equations, proving they don't have a unique solution, and analyzing the direction vectors to confirm they aren't scalar multiples. It's heavy analytical lifting, and it's where the A-star candidates shine. And this slide brilliantly illustrates the absolute key difference between an average student and a phenomenal one: connections. Principal examiner reports specifically and repeatedly highlight that candidates who reference cross-topic connections achieve significantly higher marks. Let's think about it. Generic understanding is just plugging numbers into a direction vector and hoping for the best. Connected understanding is recognizing how that vector relates to other profound mathematical principles you've learned. For instance, when you're asked to find the angle between 2 intersecting lines, generic understanding tries to memorize a disjointed formula. Connected understanding recognizes that you can just use the scalar product, the dot product, of their 2 direction vectors. You connect the geometry of the lines with the trigonometry of the cosine rule embedded in the dot product formula. You understand that if the dot product is 0, the lines are perfectly perpendicular.
The Cambridge syllabus constantly emphasizes that top students exhibit this connected, highly conceptual understanding rather than relying on isolated, disconnected facts. Let's transition over to Section 2, the procedural framework, securing the method marks. This is all about the execution. Knowing the math is only half the battle. Proving to the examiner that you know the math is the other half.
When tackling complex examination questions on vectors, especially those notoriously tricky skew line problems, top students don't just panic and start writing numbers everywhere. They ruthlessly apply this 5-step procedural framework to systematically capture every single available mark. Step 1, they deconstruct the question. They look at the command words. Are they being asked to show that the lines intersect or find the point of intersection? Show that means you already know the destination, you just have to prove the journey. Step 2, extract relevant data. Pull out the position vectors and direction vectors clearly from the block of text. Step 3, select the analytical framework. Are you setting up simultaneous equations with parameters lambda and mu? Step 4, execute with incredibly clear notation. Keep your x, y, and z components perfectly aligned. And step 5, present your final answer with the correct terminology. This systematic analysis isn't just a suggestion, it is a core established principle for mastering Topic 3.7.
Now pay incredibly close attention to this slide, because here is a crucial, absolutely non-negotiable rule. Presentation is not optional. Adhering to strict presentation conventions is mandatory for capturing every single available method mark. In vectors, notation is literally everything. The difference between a coordinate, written horizontally with parentheses like 2, 3, 4, and a vector, written vertically in column format or using IJK notation, must be completely undeniably clear in your annotations. If your formatting is sloppy, if your examiner cannot distinguish your mu from your m, or if your terminology is incorrect, the examiner is instructed not to award you the method marks. Let me repeat that. Even if your final numerical answer magically happens to be right, bad notation will rob you of the points that get you there. You are developing professional mathematical communication skills here. Stop scrolling, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Moving right along, we reach Section 3. Critical analysis, the evaluative edge. This is where we take everything we've built and push it into the highest order of exam performance.
The absolute highest scoring candidates across the world demonstrate this vital concept of evaluative thinking. They break completely out of purely descriptive robotic math to actively justify their problem-solving approaches. Think about a classic 7-mark exam question that asks you to prove 2 lines are skew. To do this, the examiner is demanding an evaluation of alternatives. First, you have to prove they aren't parallel by explicitly stating that their direction vectors are not scalar multiples. You literally have to write that sentence down as concrete evidence. Then you set up your 3 simultaneous equations using the x, y, and z components. You use 2 of those equations to solve for your parameters, lambda and mu. But you aren't done. Evaluative thinking means you take those values and substitute them into the 3rd equation. When that 3rd equation yields a mathematical contradiction, like 4 equals 5, you use that concrete evidence to state the lines do not intersect. That whole process requires justifying your mathematical decisions at every single step.
If a question specifically requires comparative analysis between different geometric scenarios, remember a vital rule straight from the Cambridge grading room. Full marks are only awarded if you identify both similarities and differences. You must use comparative connectives, support each comparison with rigorous mathematical evidence derived directly from the vectors, and draw logical conclusions about their relative relationships. For instance, what is the similarity between intersecting lines and skew lines? Well, neither of them are parallel. But the critical difference is that intersecting lines share a common coordinate in 3D space at a specific parameter value, while skew lines exist in completely separate planes, like 2 airplanes flying at completely different altitudes and different headings. They will never crash, but they are not flying parallel to each other. It's absolutely not enough to just state a fact. You must critically analyze the relationship.
To effectively manage this incredibly high level of analysis under the intense pressure of a ticking clock, you should rely heavily on this streamlined deconstruct, solve, evaluate protocol. First, break the problem into logical steps. Second, solve systematically, making sure your algebra is flawless. And then, crucially, and this is the step everyone forgets, evaluate and check for reasonableness. Does your answer actually make sense in the physical context of 3D space? If you calculate a distance between 2 points and it comes out negative, you've made a fatal error. If you find the angle between two crossing vectors and it's greater than 180 degrees, you need to evaluate your dot product calculation. This evaluate protocol ensures you don't just blindly robotically calculate an answer, but you actively prove its absolute validity.
Finally, we reach section 4, examiner warnings, avoiding the classic traps. This is our defensive strategy. We've talked about how to win points, now let's talk about how to stop losing them.
I want you to listen to this examiner alert incredibly carefully. Quote, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario." End quote. What does this mean for vectors? The ultimate trap is giving a rote-learned, generic answer that completely ignores the specific context of the coordinates provided. If an examiner asks you why two specific lines are skew and you just write down the textbook definition, skew lines do not meet and are not parallel, without actually referencing the specific contradiction you found in your simultaneous equations, you will lose the final mark. You have to tailor the answer perfectly. You have to explicitly say, because the direction vector 2i minus j plus k is not a scalar multiple of I plus 3j minus 2k, they are not parallel. Context is absolutely king, no loose threads.
If you want to put a fortress around your A grade, you need to explicitly train yourself to avoid these 3 specific fatal errors that the Cambridge examiners see year after agonizing year. Number 1, using the wrong approach for the wrong context. Don't use the cross product if the dot product is what the syllabus demands for angles. Number 2, forgetting to check your format and presentation. If you write your vector as a fraction instead of a column vector, you are throwing away method marks. And number 3, as we just exhaustively discussed, providing answers that are disconnected from the specific vector scenario given. These are the fatal flaws you must actively guard against in the exam hall.
As a quick, incredibly powerful memory hack for your exam day, I want you to permanently lock the acronym DSEP into your brain. When you turn the page and see a terrifying, massive topic 3.7 vector question staring back at you, take a deep breath and remember, deconstruct the question, extract the vector data, select your simultaneous equations, execute the algebra flawlessly, and present your findings with perfect, tailored justification. This single acronym will help you recall your strict procedural framework under the immense pressure of the exam room, ensuring you don't miss a single valuable step.
So, I'll leave you with this final, provocative question. Will you let 15% of your total exam grade completely slip away because of a generic, poorly formatted, untailored answer? Or will you actively use this examiner's blueprint to aggressively secure every single method mark available? The choice is entirely yours. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.